Welcome everybody, I'm Brian Walsh, and in today's lesson we're going over significant figures, which are sometimes called sig figs for short. And nobody likes going over significant figures, nobody likes dealing with them, myself included. But unfortunately there's really no escaping them. So it's a good idea to get comfortable with these early on.
So we're going to start by talking about figures that are significant. So all non-zero digits are significant, which means that anytime you see one of these numbers, it's going to be a significant figure. All zeros that are between non-zero digits are also significant. So this 0 right here, we can see that that is between this 5 and this 2, which means that it's significant. If we look at these other two zeros, we have a 0 here and a 0 here. Now those are next to each other, but they're also sandwiched between this 2 and this 1, which means both of these zeros are significant. Trailing zeros after a decimal point are also significant. So if we look at our example here, we have a 0 here and a 0, a 0 here and a 0 here. So these two zeros come after the decimal point, and trailing zeros mean that they come at the end of the number. So these two zeros are at the end of the number, so they're trailing, and they both come after the decimal point, so these two zeros are significant. Trailing zeros that come before a decimal point are also significant. So if we look at our example here, we have trailing zeros here and here because they come at the end of the number. They also come before the decimal point, so these two zeros are significant. The key thing to focus on this one is this decimal point. Because if this decimal point is not there, then these zeros are not significant. Now let's look at some figures that are not significant. So leading zeros that come before and after a decimal point are not significant. So if we look at our sample here, we have a 0 here, here, and here. So we can see this 0 these are all leading zeros first of all, because leading zeros mean they come at the beginning of the number. We can see that this 0 comes before the decimal point, and these two zeros come after the decimal point. But they're all leading zeros, which means that none of them are significant. And the other numbers that are not significant are trailing zeros and a whole number. And a whole number just means that there's no decimal point. So we're going to look at our example over here, and it looks just like the one we had before, except for in this case there's no decimal point. So there's no decimal point here. And if there's no decimal point there, that means that this 0 and this 0 are both trailing zeros, and this is a whole number. So without that decimal point, these two zeros are not significant. Most problems are not going to tell you how many sig figs to use in your answer. You're going to have to figure this out from the problem itself. So for multiplication and division problems, the final answer should have the same number of sig figs as the given value with the fewest number of sig figs. So you're going to look at the numbers that they give you, and whichever number has the fewest number of sig figs, that's how many sig figs you use in your answer, your final answer. For example, let's say that our problem asks us to multiply 523 times 37. So if we punch this into our calculator, what we get is 19,351. So if we want to round this to the right number of sig figs, we have to look at our given values here. So 523 has 1, 2, 3 significant figures, and 37 has 1, 2 significant figures. And our rule tells us that we need to round our answer to the given value with the fewest number of sig figs. So that means we're going to round this to 2 significant figures. So we count off 2 sig figs, 1, 2. Now we're looking at this number here. And because this 3 is less than 5, we're going to round down. So this 9 is going to stay a 9. And what we get then is 19,000. And if we look at 19,000, we can see that it has 1, 2 significant figures. Because remember, our trailing zeros and a whole number are not significant. In this example, we're doing a division problem, and they ask us to divide 139.2 by 54.5. If we punch this up in our calculator, what we get is 2.5541284404. And so in order to figure out how many numbers to round this to, just like before, we're going to look at our given values. So we start with 139.2, and we can see that this has 1, 2, 3, 4 significant figures. And now we're going to look at 54.5, and 54.5 has 1, 2, 3 significant figures. And we choose our value with our given value with the fewest number of sig figs, so we're going to use 3 sig figs for our answer. So we count off 3 sig figs, 1, 2, 3. We see this 4 here is the one we're looking at, and that 4 is less than 5, which means this 5 is going to round down. And round down means that this 5 is just going to stay at 5. And what we get is 2.55, and we double check. 1, 2, 3 sig figs. So we have 3 sig figs in our final answer, which is the same as our given value with the lowest number. So this is our answer. So the rules for addition and subtraction problems are a little bit different. In this case, your final answer should have the same number of decimal places as the given value with the fewest decimal places. So you're going to look at your given values, and whichever one has the fewest number of decimal places, that's how many decimal places you're going to use in your final answer. So if the problem that we're doing has us adding 163.3 plus 23.789, what we get is 187.089. So to figure out what we need to round this to, we need to look at our given values. So we'll start with 163.3. And if we look at this, we can see that it has just one decimal place. Next, we look at 23.789. And if we count off on this one, we have 1, 2, 3 decimal places. Our rule tells us that we're going to round this number to the same number of decimal places as the given value with the fewest number of decimal places, which means that we're going to round this number to 1 decimal place. So we count off 1 decimal place, and this 8 is bigger than 5, which means this 0 is going to round up to 1. So what we end up with is 187.1, which has just 1 decimal place. In our next example, we're taking 367.5896 minus 128.54. And what we get is 239.0496. Our first number here has 1, 2, 3, 4 decimal places. And our second number has 1, 2 decimal places, which tells us that we need to round our final answer to 2 decimal places. We count off 1, 2. Our next number here is a 9, which is bigger than 5, which means that we are going to round this 4 up to a 5. And what we get is 239.05, which has 1, 2 decimal places. Let's do a quick review of what we just learned. In this problem, we have 1400 times 2.80 equals 3,920. 1400 has 1, 2 significant figures. Remember that trailing zeros in a whole number are not significant. And then 2.80 has 1, 2, 3 sig figs. Remember that trailing zeros after a decimal point are significant. So we're going to round our final answer to 2 significant figures. So we count off 1, 2. This 2 is less than 5, so this 9 rounds down and stays the same. And what we get is 3,900, which has 1, 2 sig figs. In this problem, we have 2.65 divided by 0.015, and what we get is 176.666667. We have 1, 2, 3 sig figs here, and 1, 2 sig figs here. Remember that leading zeros before and after a decimal point are not significant. So our final answer is going to have 2 sig figs. We count off 1, 2, and we're looking at this 6, which is bigger than 5, which tells us that this 7 is going to round up to an 8. And what we get then is 180, which has 1, 2 sig figs. Here we have 6.488 times 4.007 equals 25.997416. We have 1, 2, 3, 4 sig figs here. 1, 2, 3, 4 sig figs here. Remember that zeros that are between non-zero digits are significant. So this tells us that our final answer is going to have 4 significant figures. So we count off 4. 1, 2, 3, 4. We look at this 7. Because it's bigger than 5, we round this 9 up. So this whole thing gets rounded up. And what we get is 26.00, which has 1, 2, 3, 4 sig figs. Remember, our trailing zeros after a decimal point are significant. Our final example is an addition problem, so that means we're going to be counting decimal places. We have 34.674 plus 112.2 gives us 146.874. Our first number has 1, 2, 3 decimal places, and our second number has just 1, which tells us that we're going to round our final answer to 1 decimal place. We count off 1 decimal place. We have a 7 here, which is bigger than 5, so this 8 is going to round up to 9. And what we get is 146.9, which has just one decimal place.
If you have any questions about anything, or if you have any feedback that you'd like to give me, please leave me a message. You can leave a comment, or you can email me at chemistrymadeeasy118@gmail.com. Thanks for watching.